Take this as your DBA challenge, and what I want you guys to do is below this video put down in the comments as to when do you use these reports inside Oracle database: ADDM report, ASH report and AWR report. All these three reports, in what scenarios you will use these reports is something I want to know from all of you. And meanwhile, let us start the show. Welcome back guys, and I'm excited for this episode because this is the 49th episode, and I don't know how much hard work my team has put in to find out all the questions. I would like to thank most of you who have always been constantly commenting below the videos, sending in your questions and finding answers and giving answers like this directly on dailyDBA show. I think this was one of the best ideas in 2020, and the most exciting part is this show is inspiring me to actually start the daily cloud show, and very soon means literally very soon, we will be launching daily cloud show on our own DBA Genesis channel. That being said, keep watching the channel, and please, I want all of you to help me in this goal of mine. I want to actually reach every single DBA on this planet. Please share these videos, and also when we launch the daily cloud show, I want all of you to help me spread the videos as much as possible. We need to get along as many DBAs as possible onto our platform so that we build the biggest online DBA community. Let us start today's show with the first question of the day. What is the use of locks inside database? Why can't we use the database without locks? I think this question is coming from a fresher. So you are saying that why can't the database work without locks? Now see, if you don't lock a table while you're updating, or if you don't lock a record while updating the contents of the record, what if the other person updates the record? Then what will happen? This is the reason why you need to have locks inside the database. I think I would suggest you to read about database ACID properties, and A as in atomicity. I think in atomicity this factor comes in of locking the data. So if you don't lock the data and understand 2-3 people are constantly updating the same record or the same table inside the database, then what will happen? No one will achieve their goal, or you cannot actually save the consistent data, right? For this reason, you need to log the data. Assume this guys, there is an employee table and you're trying to update the employee salary, right? The same time the other person is also trying to update the employee salary. So how are you updating the employee salary? You are actually giving 10% hike to the employee, right? That's the formula. So the first person who's trying to give the hike to the employee, they apply the 10% formula. So the salary is up by 10%, but the data is not yet saved. We are assuming there is no locking mechanism inside the database. So salary is already updated with 10%. Perfect. The same time, the other manager is also trying to update the salary with 10% formula. So what happens? This employee has probably got now around 20% of hike just because you don't have this kind of mechanism of locking. All right, just a silly example, but I hope you get the idea. So it's better if one person is updating the record, the person actually locks the record or the table so that the other people do not disturb the table. And guys, I mean, it's so simple. Let's take you are working on a document, okay? So you are creating your document. While you are creating the document, you did not even save the document, right? Will you allow someone else to put some updates into the document? No, right? Because you will first finish the document, you will save the document, and then give the document to other colleague or person to update whatever they want to update. Perfect. So it's while the document was in your system, while you were working on the document, you actually locked the document in your system and you did not allow anyone else to update the document. Perfect. The same way, you use the same concept of locking. Actually, the databases use the concept of locking so that only one person is allowed to work on the record or the table while they update the data, and I think that's a good thing. Perfect. That being said, let's move on to the next question. Our reporting team directly works on production database, and my client is insisting to give a dedicated database which will act as copy of production database. What are my options? See, there are probably three main options that you can go with. First one is the golden gate. But the challenge with Golden Gate is it is costly affair and you need to actually purchase the license. The second option is the snapshot standby, but the problem with snapshot standby is while you convert a physical standby into a snapshot standby, the physical standby, like the logs that are coming from the primary to the physical standby, they will not be applied onto the snapshot standby unless you convert the snapshot standby back to physical standby. So due to this problem, probably snapshot standby might be good for some small level testing, or probably you want to test or give the system to development team for a particular period of time, like probably for 24 hours or 12 hours, then you convert that back into the physical standby, then it's fine, right? But snapshot standby, still you cannot use it full-fledgedly as a standalone copy database. The next option is export import. You export and import into a test database whatever the schema or the particular table that you want to give your client as a consistent copy, right? Also, there are other options like you can go for ARM and cloning and all, but again it depends on the scenario. See, I'll tell you what, I have mentioned this 100 times in my previous videos also, still I'll mention it now. Every strategy inside the Oracle database that you choose, every method, every step, every tool that you choose, it all drills down to the database size. And also in your case, like if your client is insisting to create a reporting database, then probably you can also go for Active Data Guard, right? But once again, everything, as I mentioned, it depends on the size of the database or the size of the schema or size of the particular table that you are going to work on. So if it is a very small table, you can go for export import. If it is schema and then you want to have a clone of the schema for a reporting team, then go for Golden Gate, or once again you can use export import. But again it depends what is the size of the schema. And then you have the snapshot standby in case if you want to give the entire production database as a test database or reporting database to a team, or else if it is only for reporting or select queries, then you can always go for Active Data Guard. But remember, for Active Data Guard you need to have a separate license. Even though if you have a enterprise edition license for the primary database, still you need to buy a separate license for Active Data Guard. That being said, let's move on to the next question of the day. In one of the interviews, I was asked in what scenario an inactive session will block an active session. I really don't know the answer. This is a simple one, but the beauty is this is actually attached to our first question, that is, what is the use of locks inside the database? Now see guys, okay, first of all, let us understand on a fundamental level. When do you think one session becomes inactive inside the database? So first of all, you need to understand what is active and inactive sessions. Most of the fresher DBAs or even most of the experienced DBAs, they think that if you are connected to the database, then the session becomes active. No. When you are running a query inside the database, that's the exact time the session becomes active. And when the session is only, or when the user is only connected to the database, for this connection, while the user is not executing anything, the session will be inactive. Perfect. Once again, when the user executes a query, the exact execution, if a query is being executed, the session will be active. If no query is being executed, but still the user is connected to the database, the session will be inactive. Perfect. So now we are clear with the active and inactive sessions. Now coming back to this question, in what scenario an inactive session will block an active session? Very simple. So one session tried to update one record. Perfect. Now this record, definitely Oracle will give the lock to the user which was trying to update the record. So while the record is updated, right, while the execution was happening, the session became active. But after the update record, the session becomes inactive. Now the session is inactive, but it holds the lock for the record or for the table, whatever it was trying to update. Perfect. So this inactive user, how it has become inactive? Because it's not executing any query inside the database. So this user is inactive as of now, and the user did not even issue a commit. So if commit is not issued or if rollback is not issued, the user will still hold the lock for the table or the record. Perfect, very clear. If the record is already locked by an inactive session, so why this session is inactive? Because the user is not executing any query inside the database, and also the user did not issue a commit or rollback. So what happens? If the other user tries to update the record inside the database, then the other user will get, or other user session will be blocked, because the the record is actually locked by an inactive session. So once again guys, inactive means the user is not executing any query inside the database. Very simple, straightforward. If an inactive session tries to, or if a user tries to update a record, the user will get the lock. Perfect. The user will lock the record. Oracle will give the lock to the user, and after updating the record, the user never issues the commit or rollback, but still connected to the database. So what happens? The other user cannot update the record because lock is held by an inactive session. What is inactive session? A person who is just not executing any query inside the database, but still connected to the database. Exactly at this point guys, I am on my system, okay? I am not touching the keyboard or the mouse. So I am connected to this system, but I am like inactive. Perfect. So as I move the mouse, the session will become active, and the same thing happens inside the database. If a user is executing a query, it becomes active, and if a user is not executing query like this, I'm not touching my system, I'm an inactive user. Perfect. So as I touch the mouse on my laptop, what happens? My session changes to active because there is some kind of activity that I'm doing on this system. That being said, let's move on to the next question of the day. Every time my team performs an import, they have to drop the constraints and indexes. Post import is done, we create the constraints and indexes. Is there any simple method for same? Of course, there is a simple way. My question is, why are you dropping the constraints and indexes? Like, you don't have to drop the constraints. What you can do is you can disable the constraints and then perform the import. Once import is done, then you enable the constraints. The same thing goes with indexes. Like, you actually set those indexes to unusable and probably rebuild those indexes once the import is done. So keep it simple. Like, of course, I understand this happens in many of the environments. What they do is they drop the constraints, and in some of the real-time production databases, guys, I've seen there are so many constraints on tables, and to create those constraints, sometimes it takes more time for creating the constraints than it has taken time to perform the import. So I would suggest, like, what you do is just disable the constraints. Okay, so once the import is done, you enable the constraints. Very simple. The same thing with indexes, you put them to unusable and then you rebuild those indexes once the import is done. Keep it simple. This is the simplest method to do it. That being said, let's move on to the last question of the day. How to find performance bottleneck of a query? It's very simple and straightforward, and I believe, guys, we should actually have a show for Oracle performance tuning probably in some time. So for this one, guys, I am surprised, like, whenever I see DBAs, and if you notice the DBA challenge that I gave all of you, I have to tell you this, guys. I see so many experienced DBAs, and when they are working on the Oracle database, I'm always surprised. So if there is a problem with the query, they always run for AWR. Like AWR, you should look at AWR, no doubt, but that's why I asked all of you this DBA challenge as to, like, I want to know if you guys are clear as to when to use AWR report, when to use ADDM report, when to use ASH report. So there are particular scenarios only when you have to use these reports. So I'll keep it as your DBA challenge. I'm not going to answer this question. Let's come back to finding the performance bottleneck of a query. So you have a query and it is having a performance challenge. And no surprise, but I see so many DBAs, whenever there is a performance tuning issue, the first thing they check is AWR report. And my question to them is, like, when do you check AWR report, or in what situations you should check AWR report? And the surprising answer is every experienced DBA thinks that if there is any performance issue inside the Oracle database, they must consult the AWR report, and that is the biggest loophole. To answer this question, if you have a problem with a query, you should actually check the tkprof utility. So what you should do is you should take out the trace of the query, you open the trace file using tkprof utility, and then you actually check the execution of the query as to where the query is spending time. Surprising thing, not many DBAs actually know about the tkprof utility. So what I would suggest is, for all the DBAs who are listening to this video, I want you all to try to run the tkprof utility against the normal queries that are running inside the database, just to become more familiar with the tkprof utility. So once you generate the trace of a query, you read that trace file using tkprof utility, you will get a lot of details as to exactly where Oracle is spending time while executing the query. Now when you have this data, like where exactly Oracle is spending time, you can work your way to improve those areas to speed up the execution. No doubt AWR report is awesome, but AWR report is for a time period, okay? So like it is for a snapshot interval. But if you want to work with a single query where you know the query, you know the problem with the query, you know that someone is complaining about the query, you know that someone is saying that, hey DBA team, this is the query and we have a problem with this query, then you should actually go for the tkprof utility. Run that query, generate the trace, read the trace files. Trust me, the amount of data that you will get and the amount of details that you will get, if you work on those details as to where exactly Oracle is spending time in executing the query, trust me, you will literally improve the performance of any query inside the Oracle database. That being said guys, let's move on to the most exciting part, and that is the bonus question. We are back guys, and guys, this one question someone asked me, like in one of the previous episodes I mentioned this, you know, like having more indexes on your tables and having more number of constraints, it might actually slow down the database process, or when you try to insert the records into the table, right? So like someone asked me this question, like how, and I want to like probably you all can take this as one more your DBA challenge. What I want you guys to do is, on a test database, create a table. Okay, so take this as scenario number 1. So once you create this table, it's an empty table which is not having even a single index, and it is not even having any constraints. Now you try to create a PLSQL loop that will insert 10 million records into this table. What you will observe is, I want you to note down the time it has taken to perform the insert. Perfect. This is scenario number 1, a table without any index, without any constraint, and you inserted 10 million records. Now for the same table, what you do is you create one index and once again try to insert 10 million records. Probably try to delete the earlier records and then insert back again. This time, if you note the time it has taken to perform the insert of the 10 million records, it will be more when compared to the previous scenario, right? Let us take scenario number 3. What you do is create index on all the columns of the table. So if you have 4 columns on your test table, that means you will create 4 indexes on the test table. Each column will have its own index. This time, once again, truncate all the previous records, run the PLSQL loop, insert 10 million records again into the table, and this time if you compare, it will take more time compared to the scenario 2 and compared to the scenario 1. We will go one step further, guys. In the 4th scenario, what you do is you actually create one constraint on one column of this test table. So you have 4 columns and you have 4 indexes. With 4 columns and 4 indexes, create only one constraint on any one column. Once again, delete all the records from the table and use your PLSQL loop to once again insert the 10 million records into this table. This particular time, what will happen, you will observe Oracle has taken more time compared to all the previous scenarios, right? What I want you to do is, try practicing this and put your comments below this video, and I would like to know, were you able to identify the difference as to when you add more number of indexes and when you add more constraint onto a database table, it will actually hit the performance of the database inserts. That being said guys, let's meet in the next episode. Till then, take care. Bye bye.